Imagine two worlds, both hostile to human life, yet both conquered by our ingenuity. One lies deep beneath the waves, a realm of crushing darkness and immense force. The other stretches high above the clouds, a place of brilliant light and air so thin it's almost a vacuum. These are the domains of the submarine and the jet fighter, marvels of engineering designed to venture where we cannot survive unaided. Their greatest challenge is not a visible enemy, but an invisible one: pressure. Pressure can squeeze a steel vessel like a tin can or cause a human body to fail in an instant. Down in the ocean's abyss, the weight of water creates a pressure almost beyond comprehension. As the jet fighter climbs, the pressure outside drops away to almost nothing, a vast empty expanse. Both environments are utterly unforgiving. Survival depends entirely on the machines we build. The engineers who design these craft are like artists, sculpting with metal and technology to create safe havens in the most dangerous places. A single flaw can lead to catastrophic failure. Let's embark on a journey into these two contrasting worlds, diving into the silent depths with submariners, then soaring into the sunlit emptiness with fighter pilots. This is the story of how we've learned to navigate the pressure frontier and expand the boundaries of our existence. Pressure is all around us, but we only notice it when we leave the surface. As we descend into the ocean, water's weight increases pressure rapidly. 1 atmosphere for every 10 meters. At 300 meters, a submarine faces 30 times the pressure at sea level. At the deepest trenches, the force is unimaginable, like 50 jumbo jets pressing on a single person. In the sky, the opposite occurs. As a jet climbs, the air thins and pressure drops. At 10,000 meters, air pressure is just a quarter of what it is at sea level. At 18,000 meters, it's less than a tenth. The deep sea threatens to crush from the outside. The high sky threatens to explode from within. Submarines must be fortresses, resisting the ocean's squeeze. Jet cockpits must be sealed, holding precious air inside. Both machines create a small artificial piece of Earth in the most unearthly places. It's a delicate balancing act against the fundamental forces of our planet. The contrast is stark and absolute. Survival depends on maintaining that fragile bubble of life-sustaining pressure. To survive the deep, a submarine's pressure hull must be incredibly strong. Built from high-yield steel alloys, its cylindrical shape resists the ocean's uniform force. Every weld is inspected for flaws. A single crack could be fatal. The hull is a fortress wall holding the ocean at bay. Inside, the crew lives in a bubble of normal air pressure, isolated from the crushing world just inches away. Many submarines have a lighter outer hull that floods with seawater for streamlining and houses equipment like ballast tanks. Ballast tanks control buoyancy, allowing the submarine to dive, surface or hover. Propulsion is designed for stealth. Nuclear reactors power quiet turbines, and even the propeller is engineered for silence. Every machine is shock-mounted to prevent vibrations from betraying the sub's position. In the deep, silence is survival. Every detail is engineered for strength, stealth and endurance. The pressure hull is both shield and sanctuary. Life on a submarine is lived entirely within steel walls, with no sunlight and only recycled air. The most critical system is life support. Scrubbers remove carbon dioxide and oxygen is replenished from tanks or by splitting water. Fitness is managed with compact equipment. Food is carefully planned and stored for long voyages. Clean water is produced on board by desalinating seawater. Psychological challenges are as demanding as the physical. Submariners are selected for resilience and trained to manage stress and work as a team. Routine is everything. Shifts for work, sleep and recreation create a sense of normalcy. Emergencies are ever-present risks. Fire or hull breach deep underwater is terrifying. Every crew member is trained in damage control, practicing firefighting, sealing flooded compartments, and using emergency breathing gear. The submarine has redundant safety systems, watertight doors and emergency ballast blowers. Preparation and training are the ultimate lifelines. In this dangerous world, discipline and teamwork are survival. The submarine is a self-sufficient world, isolated but prepared. Every day is a test of endurance and cooperation. A jet fighter climbing into the stratosphere faces the opposite challenge of a submarine. It must keep the inside air from escaping into the near vacuum outside. The cabin pressurization system uses cooled bleed air from the engines to maintain safe pressure. The cockpit isn't kept at sea level pressure, but at a cabin altitude, a compromise between safety and structural limits. If pressurization fails, the pilot's oxygen mask provides pure oxygen, sometimes under positive pressure, to keep them conscious. The thin air affects flight. Wings generate less lift, so jets must fly faster, often supersonic. Jet engines are designed to gulp down thin air and generate immense thrust. The cockpit is a bubble of life in a hostile environment. Every system is engineered for survival at the edge of space. The balance between human needs and machine limits is delicate. High-altitude flight is a constant battle against the void. The jet fighter is a shield against the emptiness above. The human body is tuned to sea-level air. High altitude brings severe risks. Hypoxia, lack of oxygen, can cause euphoria, confusion and unconsciousness in minutes. Rapid decompression is another danger. A shattered canopy can cause explosive loss of pressure and severe injury. Above 63,000 feet, water boils at body temperature. Ebullition is instantly fatal. Pilots wear specialized gear. G-suits prevent blackouts during high G turns, and pressure suits act as personal spacecraft at extreme altitudes. If cabin pressure is lost, the suit inflates to protect the pilot from hypoxia and the near vacuum. Helmets have tinted visors to shield eyes from the harsh, unfiltered sun. Pilots must constantly monitor their own state, the aircraft and the tactical situation. Flying a fighter jet is one of the most mentally demanding tasks imaginable. The environment is unforgiving. Survival depends on training and equipment. Every second at altitude is a test of human limits. The margin for error is razor thin. Only the best prepared survive the ordeal. Submariners and fighter pilots are shaped by intense selection and training. Submariners must handle claustrophobia, isolation and constant stress, learning every system and emergency procedure. Teamwork is essential. Everyone must be ready to act as firefighter, medic or engineer. Training includes escape drills and simulated emergencies, building technical skill and mental fortitude. Trust between crew members is absolute. Fighter pilots face different demands. Physical training pushes their bodies to the limit. The human centrifuge simulates G-forces. Hyperbaric chambers teach them to recognize hypoxia. Psychological training is just as intense. Pilots must process information and make split-second decisions under extreme stress. Simulators allow safe practice of complex missions and emergencies. Whether deep in the ocean or high in the sky, the human element is the most important component. The machines are remarkable, but it's the courage and resilience of the people inside that conquer these frontiers. Extreme environments demand extraordinary people. History reminds us of the dangers of extreme pressure. Sometimes the pressure wins. The loss of the USS Thresher in 1963 was a tragic lesson. A failed pipe led to catastrophic flooding and implosion. This disaster led to the SubSafe program, revolutionizing submarine safety standards. In the sky, rapid decompression is equally deadly. In 1999, a Learjet lost cabin pressure. Everyone on board succumbed to hypoxia and the plane flew on autopilot until it crashed. These events highlight a fundamental truth. Survival depends on maintaining a fragile bubble of pressure. A breach is catastrophic, whether from the crushing sea or the empty sky. Disasters force engineers and operators to improve every system and train with greater diligence. They are powerful teachers, driving progress. For all our technology, nature's power is absolute. We venture into these realms with respect and hard-won lessons. Every advance is built on the memory of those who came before. The challenge of conquering extreme pressure drives innovation forward. Submarines of the future will use stronger, lighter materials, titanium, carbon fiber, to dive deeper and stay longer. Advanced propulsion and artificial intelligence will make them quieter, smarter and safer. In aviation, the push is for higher, faster flight. hypersonic jets at the edge of space. Smart cockpits will monitor pilots' vital signs and take control if needed. These technologies will push boundaries even further. From the abyss to the stratosphere, the journey continues. Submarines and jet fighters are symbols of our drive to explore. They show our ability to build machines that let us survive where we were never meant to go. As we develop new materials and smarter systems, we'll keep pushing the frontier. The pressure frontier is not the end. It's the beginning of new possibilities. Our desire to see what lies beyond will always propel us forward.